In the 1960s, New Zealander Bruce McLaren was a star on the racing circuit. Killed at Goodwood during a practice run, his name has lived on through the internationally renowned British team. Until their disastrous 1995 Formula One season, they have been the most successful Grand Prix team in the world. But Bruce McLaren left another legacy. He wanted to produce a road car with the guts of a racing machine. In 1989, McLaren put Gordon Murray, their Formula One designer, to the task to make a street-legal sports car with racing technology, never before seen off the track. In 2.5 years, the McLaren F1 supercar was built.
That's main.
All my life I can remember, I'd wanted to do a road car and a sports car, and to be given the opportunity by the group to do one for McLaren at this level was like fairy tale stuff, really. I'd always had in my mind a sports car, a certain layout, that is, with the central driving position and the two seats on one side. I think that was going back to college days when I first penciled that one. We spent a long time on deciding how we could achieve the access to the central seat. And in the end, we had to come up with these dihedral doors that actually remove part of the floor in the opening process. And it's not the easiest thing to do, but once you've done it about 6 times, it's getting in and out, that is, it's actually turned out okay. And it's part of the character of the car. I think people, with sports cars, people will stand a certain amount of acrobatics to get in and out.
Yeah, that's okay. It's a bit clumsy looking. Yeah, it is a bit. No, it's a one leg at a time job getting out.
The shape of the exterior developed simultaneously with the interior. Scale models were carved in clay and tested for aerodynamic efficiency on the Formula One rolling road wind tunnel. Fluorescent paint was used to mark how the air flowed across the chassis.
We did about 1,100 wind tunnel tests in the Formula One tunnel to produce this car. You're looking for enough downforce to cancel the natural lift. All cars produce lift, basically. And when you're talking about a car that can exceed 200 miles an hour, that lift figure becomes quite critical. So you have to produce downforce to counter that lift to make the car stable.
To maximize the power-to-weight ratio of the car, Murray needed a super light body. He used Formula One's carbon fiber. At 36 pounds per square meter, it's expensive, but it's 5 times the strength of steel. Murray's designs, like this driving section, were broken down into cubes to calculate how many layers of carbon each area needed to cope with the stresses of road conditions.
Unlike a metal where you start with a constant thickness material, unless you do a lot of machining work, you're pretty much stuck with that thickness all the way through the panel that you're making. With composite materials, what you have got is a situation where you have layers of material that you can put down where you need them, in the direction you need them, and where you don't need them, you don't put them. The objective for optimization of design is actually to get that to one color. That says that in that particular loading situation, the shear stress across that structure is constant.
Carbon fiber is at the cutting edge of engineering design, but ironically, the car must be constructed entirely by hand. 5,000 chassis sections are molded on the factory floor from Paul Martin's plans. The loose weave components are then baked hard in a high-pressure oven. In here is the roof section, vacuum-packed in heavy-duty plastic. After 3 hours at a top temperature of 121 degrees centigrade and a pressure of 75 pounds per square inch, the carbon fiber of the roof has gelled solid. Carbon fiber can be laid down to maximize strength or give. In head-on collisions, the nose cone fibers fracture gradually, absorbing the energy of the impact. This is the only car to have been driven away from the statutory 35 miles per hour crash test. But the F1 is built for speed. With its bespoke BMW engine, the F1 peaks at 231 miles per hour.
We decided really that the car should be at a new level, at a higher level of technology, finish and performance, and that it should be above all a driver's car. I was determined the car wouldn't have things like power steering, power brakes, ABS, all the things that detract or anaesthetize the driver, if you like, from the actual feedback. It means going on a space ride. I'll never get used to, I'm sure, banging the throttle open. It's just neck-snapping stuff.
Ready, right now, bang! There you are, 7,400 revs in third, 7.4 in fourth, 7.4 in fifth, 150 miles an hour. Brake down heavily, into fourth, into third. Tight corner here at the end of Hanger Straight. Car sliding a bit, power on hard. Here we go out again.
This engine really is something special. It gives 627 horsepower at 7,400 revs. It has over 600 Newton meters of torque between, I think, 4,000 and 7,000 revs. And it has over 80% of its maximum torque at a lowly 1,500 revs. That basically, in layman's terms, means that the car pulls like you wouldn't believe from very low revs, gives tremendous flexibility and drivability. So it means that the car is very docile if you want to drive around in normal fashion. But when you do press the accelerator, the performance is just utterly awesome.
The F1 accelerates from 0 to 100 miles per hour in 6.3 seconds. Over 150, it out-accelerates most Formula One cars.
Because the car, above all, had to be a driver's car. And to get the throttle response and the control and balance of the car in fast cornering on the throttle, you need a normally aspirated engine. Turbocharged engines give you too much lag, not enough control over the balance of the car, the balance of the chassis, when you're driving the car fast.
This we're rather proud of. It's rather nice. And it's been produced for us by a French tool company, Facon. And it's the world's first titanium toolkit. Now, these are like jewels. And they're so light. They're like a feather. Nobody's ever made tools out of titanium before. We hope, of course, that the owner never needs them with a car, but it really is rather nice to have them. Here is all the electrics of the car, all the fuses and so on, and the battery. But up here is something which is very, very unusual indeed. It's the first car in the world to have a telephone modem link. Now, we have a little modem link which plugs into there and can download from the engine management system all the information wherever the car is in the world back to our computer here at base. So if for any reason we have a small fault or problem in the electrical system or the engine itself, which is very unlikely, but if it does happen, we can check it out with that and probably diagnose what the fault is. If you look here, you'll see something else rather unusual. You see an awful lot of gold in this car. Now, this is actually genuine 24-karat gold, and it's there for a very good reason. This engine and the catalytic converters here all generate a colossal amount of heat, which you've got to get rid of. But of course, you can't get rid of it all, because some of it's going to come up through the bodywork, some of it's going to try and percolate through into the cockpit. So this gold foil, which is genuine 24-karat gold, is used as a heat reflector, and it's one of the most efficient heat reflectors known. So the fact that we've probably got about £2,500 worth of gold in the car is actually there for a very good purpose. It's normally used on, you know, the sort of space shuttle and that sort of thing to stop frying astronauts. And here we use it so we don't fry the paint and we don't fry the occupants of the cabin.
Despite the formidable engine, the state-of-the-art carbon chassis and their titanium toolkit, since the launch 3 years ago, McLaren have only sold 55 F1s. Their reputed business goal is to sell 300 in 12 years. Has the F1 crash landed? If it has, orders from an unexpected quarter have cushioned the blow. 5 racing teams saw the F1's potential for endurance sports car racing. McLaren had 3 months to modify and deliver before the season began. They scrambled to make the F1 an endurance racer, to be driven not by McLaren's own works team, but as a turnkey car, ready to race on delivery by independents. Amid cocktails and canapes, the GTR was launched. By the first race, 4 teams had their GTR, one sponsored by West Cigarettes and run by David Price, an experienced manager who started as a mechanic.
Done it since I left school, really. I did a Ford apprenticeship as a mechanic, and I've been a mechanic ever since. Just made a few quid at it, I suppose.
The 5th GTR to roll off the production line was ordered by Moody Fayed, the 26-year-old son of Saleh Fayed, the owner of Harrods.
As I approached McLaren myself, I just thought it was a little kid, you know, asking for some candy or something. I don't know what it was. They got to take me seriously when we paid the deposit for the car, which was £150,000. Then they took me seriously, but not before.
The late order means that Moody's car joins the championship well into the series for race 4, competing against teams who know their cars backwards. But McLaren have had these races to improve on the GTR's design and will build these improvements into his car. Moody's venture will cost well over £1 million, but his confidence has been buoyed because the GTR has won every race so far.
I mean, it is an expensive car, and it is a lot more than an F40 and a hell of a lot more than a Porsche. But I suppose all the time it's winning, then it doesn't matter how much it costs. Well, I'm not buying it, so it doesn't matter to me.
Moody Fayed is buying it, but he knows nothing about motorsport.
Most of that deal come through McLaren's. The McLaren's said, could I come up and meet Moody that afternoon? And I went, we did a deal pretty much straight away. Moody's easy to do a deal with. The situation we've got now is that West sponsor one car, which is primarily a German car, if you like, and Harrods are sponsoring the other car, and we just try and gel them together into one